Hi, I'm Mike Shepard from GrowthPoint. In 2017, I did a video blog called Machine Learning in the Marketplace. As we in technology know, there are waves or eras of technology, and I think we're now in the era of AI. So this video blog gives a history and some context to those seeking to garner a perspective on AI as to why now is the era. AI has mostly been pioneered by mathematicians and computer scientists. And while computing was first thought of a really long time ago, back in the 1820s through 1832, when Charles Babbage released his paper on the difference machine, the next sort of foundational mathematician was over 100 years later with Alan Turing, where he really pioneered electronic computing and created the bomb, which is this huge computer in Bletchley Park that broke the Enigma code. And he also pioneered this idea of machine intelligence and created this concept of the imitation game, otherwise known as the Turing test, which is really the test that a computer is indistinguishable from a human. So the next mathematician that really coined the phrase artificial intelligence was John McCarthy. He was a Caltech graduate and worked in many of the preeminent American academic institutions. And in 1956, he coined the term artificial intelligence at the Dartmouth conference. And then 10 years later, Joseph Weizenbaum created ELIZA, which was a rudimentary chatbot that initially just did very simple back and forth interactions, but ultimately was developed to the point of passing the Turing test and couldn't be distinguished from a human. So between 1966 and 1972, the Stanford Research Initiative really focused on everything AI, and they created Shaky the robot, which had some basic visual analysis or early computer vision, and was able to do route finding and figure its way around things and object manipulation, rather like humans. So several human-like activities. And then right in the late 1970s and 1978, Jeff Hinton got his PhD from the University of Edinburgh in neural networking, which was a really fundamental part of the future of AI as we know it today. So, as you know, you cannot make a skyscraper without elevators. There were lots of components that needed to be developed in order for the thing that we know today as AI to be feasible. And it all happened during the sort of quiet period of AI, which was the next 20 odd years from the late 70s into the early 2000s. And during that time, a lot of the components were developed, commoditized, and proliferated to the point of ubiquity. Think of microcomputers, so desktops, laptops, mobile phones, mobile telephony, early tablets, so things like the Palm Pilot, sensors that can see or detect heat, detect digital cameras for moving and still images, digital sound, both for recording or for editing, OCR, so optical character recognition, where a computer can actually read text, and OMR, where it can identify marks and objects. Lots of things like speech recognition, looking at the digital sound pattern, being able to create a text version of what's being spoken about. Image recognition, being able to see the difference between a bicycle and a truck and a car or a person. Face recognition. And then along with that, a lot of infrastructure stuff like databases that can store and retrieve images and videos and search them, natural language processing, everything became connected, so the whole emergence and proliferation of the internet, everyone started to communicate digitally, so there was email and lots of text that was put on websites that could be indexed and searched and used as a knowledge base. Digital encyclopedias. The first driverless car was created in the late 80s in Germany and then taken to a whole new level by Akash Deshpande at Berkeley in the late 90s, where he drove 5 autonomous vehicles around Los Angeles. And then IBM released Deep Blue, which actually managed to win 1 out of its 6 matches with Garry Kasparov, and then on the rematch won all the chess matches because it could process 200 million moves per second, far beyond anything a human could do. And then in the late 90s, I think in 1998, Google was founded, and then Dr. Cynthia Breazeal of MIT created Kismet, which was this robot that could mimic and also express and read human emotions. So The world took a pause at the end of the 90s for Y2K and rewriting a lot of computer software to deal with the end of the century. And then in the beginning of the 2000s, the pace started to really gather steam, where NASA had built its autonomous Mars rover, and then during the early part of the century we're in now, a lot of the really components of AI started to come together. Several years later, in 2006, Fei Li, a Princeton graduate, Caltech PhD and Stanford professor, created ImageNet. ImageNet is a 15 million image curated data set for training AI models. And now the models needed to train robots and AI agents to perform spatially intelligent activities to assist us in everyday life. Fei uses a fundamental analogy when it comes to AI. Her analogy is as follows: the development of eyesight and vision in nature from primordial trilobites to the modern animal kingdom, and its corresponding development of nervous systems and spatial intelligence being repeated at an accelerated pace in digital imagery, digital data networks, and AI models that will drive spatial intelligence in robots. In 2010, DeepMind was founded out of University College London, and DeepMind was a very advanced, heavy compute. They came out of I think the computational neurobiology or something like that out of UCL. And in 2011, Watson, so this was 15 years after Deep Blue beat Kasparov, Watson managed to win Jeopardy, which was a whole new level of processing, because it was really listening to questions and answering questions like a person. And in the same year, Greg Joswick from Apple saw Siri and acquired Siri and then built it into the iPhone. And so thereby delivering AI, or more of command and control type of AI, to 1 billion people around the world. Alexa from Amazon came out a few years later, where it got deployed into people's homes, where people can say, "Hey Alexa, play 70s music," etc. And then now we're starting to get to the point whereby some serious resources are being applied to AI. So you've got Amazon, Google, Microsoft, the big guys. In 2013, Jeff Hinton joined Google. Remember that Jeff was the father of neural networking. And in order to get really limitless resources so that he could really pioneer in the field. The year after Jeff joined Google, they went and bought DeepMind and really pioneered this recursive learning neural networking technology in the form of reinforcement learning, where they could look at the game Go and learn all the moves of Go and then actually beat the world champion in Go. And the DeepMind technology, which they turned into AlphaGo, could learn all the moves of Go in one night and beat the world champion the next day. So that was a really huge feat in terms of recursive and reinforcement learning. And that has now, more recently in 2020, that's been applied by a company called OpenAI to the entire body of knowledge in the internet. And it updates every day as the internet adds more and more knowledge. And so they created these things called LLMs, or large language models. And those large language models are sort of a different type of model from a historic machine learning model. And they use this reinforcement learning to constantly build and can synthesize answers from the text in the internet. So using all the previously known natural language technologies, as well as they can do it for images and for sound. When it comes to computer vision, diffusion models and score-based generative models are mainly used for image denoising in painting, super resolution imaging, image generation, and video generation. These generative AI models, otherwise known as generative pre-trained transformers, or GPT, you'll have heard of ChatGPT. They use the entire body of the internet to create these incredible tools for delivering AI to everyday people. So where we're at now is last year Microsoft integrated ChatGPT with Bing, and Google also created Bard, which they rebranded Gemini. which is their version of OpenAI's ChatGPT. And so millions and probably billions of people today are now starting to use AI in their everyday life, not only on their iPhones with Siri, but also when they search for things. And it could actually evolve into the next generation of search. So enterprises are starting to use AI in the form of retrieval augmented generative AI, where they actually take their corporate data coupled with the LLMs and help their employees perform better, produce more productively, and work more effectively in their jobs. As OpenAI, Gemini, Anthropic, and other costly frontier models have been created, there's been a significant open source movement to build less costly LLMs such as Mistral, Llama, and DeepSeek. As technology has proliferated and become really ubiquitous, even at the edge of the networks, and the network capacity is now huge. Almost everything is connected, almost everything has a processor in it, and the youth of tomorrow will essentially expect there to be an AI-driven digital twin of almost every device that they have to interact with, so that they don't have to spend hours reading manuals or learning how to use things or learning how to navigate to classrooms or through a hospital. And AI will essentially be embedded in our environment. So currently the market is rewarding the infrastructure players in AI. However, in the next phase, we see a drive towards lower cost, local, and less CPU intensive AI, using new AI chips, AI NPUs, and other technologies such as quantum inspired reduction. And we also see a drive towards maintenance and operation of AI models at the edge to empower AR, VR, MR, and XR industrial systems for training, maintenance, operation, and support. In addition, we see new vision-driven and synthetic data-driven models, such as those developed by Fei-Fei Li's new company, World Labs, to support more rapid implementation of new application-specific models and digital twins. These and other new AI technologies, such as holography, will accelerate new image-dependent simulations, and these will use synthetic data and images to offer improved training of models, as well as more use of NERF and related technology to allow computers to fill in the gaps when they do not have the whole picture. All these new developments will change the user interaction experience and ultimately lead to AI agents that supplement and enhance workers and occasionally replace them, while still keeping a human in the loop when necessary. We really see at Growth Point, every company we interact with has AI built into their products in some way, or is building AI into their products in some way. And we believe that now is the era of artificial intelligence. And so we're very excited about it, and we think that we're going to get extremely busy in the whole realm of AI.